Hello, people of the internet. Today, myself, Jared Dunn, a crypto enthusiast and expert, having worked on many engagement firms with dozens of ICOs and missed more than one opportunity to be the crypto millionaire. We're going to look at how to analyze Ethereum gas usage and other fees on the blockchain today, later on a live stream. During this project, we'll have a look at the mechanics of gas on the Ethereum blockchain, different ways to analyze and consume the information in order to make educated decisions about spending gas. We'll also look for other fees on the blockchains, why they're important, and how they either may be prohibitive or enabling. Here's the overview. We're going to look at ETH first. What is ETH gas? How is it defined? How to set gas limit and gas price on different blockchain interfaces. Looking through old Etherscan transactions, we can see the importance of ETH gas to be quicker than other parties. So we'll just look up some ETH transactions. In session 2, we'll go into the ETH gas station, which is a website providing valuable information surrounding Ethereum gas. What's on the landing page, what's on the TX calculator page, what's on the TX pool vision page, and gas burners page. In session 3, we'll look at Bitcoin fees, why they're becoming higher and higher, what solutions exist to offset the high Bitcoin transaction fees, who benefits from Bitcoin fees, and who loses. In section 4, we'll look at zero transaction fee blockchains like EOS, gas, and etc. How can a blockchain achieve consensus without TX fees? What does zero TX fee blockchain mean for us? Potential use cases like what I like to call a drip-drop financial rewards and wages system. In session 5, we'll look at fees and how they interact with the ideal or max transactions per second of a blockchain, specifically Bitcoin, Ethereum, and next-gen chains like EOS and Neuron Chain. We'll compare the TPS of blockchain with the traditional venues like PayPal, Visa, MasterCard. In session 6, we'll have a conclusion. So all in all, we're going to learn lots about Ethereum gas and different transaction fees on blockchain, and we'll be going through that today later on a live stream. Thank you very much for your time, and hope to see you there.
Hello, people of the internet. Here we go. We're live. I think the live stream's working. I don't know if Pete's going to check. Hello, people of the internet. That's not good. I mean, that is good. It means you can hear me. I'm glad you can hear me. Here we are in our first session of how to analyze Ethereum gas usage and other fees on the blockchain. So let's take a look at the project overview. The first session we're going to look at is what is ETH gas and how is it defined? Well, this question comes up often. I know that when I was applying for work at different blockchain organizations and engagement firms, that was actually one of the questions on the application. I wonder if we can pull that up right quick if they have a current one on We Work Remotely. I don't know if they do or not. They have one listing. It might not have that question involved though. No, it doesn't. So what we got to do then is take a look at what my answer was, maybe. See what I came up with when I was asked this very same question. Hey, Matt. Matt. Thank you. What is Ethereum gas and how is it used? Well, I got a job with this answer. Gas is an Ethereum transaction. In an Ethereum transaction is denoted by the limit and price and is used in the calculation for how much fees will be paid on that transaction. With higher gas limit and price, we can expect that transaction to be accepted by the blockchain and confirmed quicker than lower gas transaction made at the same time, all else remaining equal. Well, that's pretty much it. Gas is the fee you pay on Ethereum to do transactions, to create contracts. Here's an existing transaction I have apparently to create a new contract that was pending since the last time I opened MetaMask. So here's where I can set the gas limit, the gas price, and what happens here is these are multiplied together to give you the total gas that might be used for that transaction. So let's reject that transaction. Let's take a look at maybe my multi-sig contract on the Ether mainnet. I wonder how much gas that cost me to create. Let's look at the transaction. So Paytech confirms the stream is good. So I created this contract from my address. I paid just a little bit of Gwei. Apparently I didn't have that much money to play around with, so I paid 1.21 1 to 1 Gwei in gas price, and my gas limit was 400. Oh, what is it here? 4 million, and the actual gas used by the transaction was less than that. It didn't need the whole gas limit that I set, and it only used this much, which actually turned out to be 67 cents in gas to create this contract. You don't usually need to pay 67 cents in gas to do stuff. Let's take a look at my address and see something that costs less gas than that. Let's look for something where I just sent ether to somebody. Here's one here. So I paid 67 Gwei, which is actually tons. That means that it would have happened relatively quickly. And we'll see that when we look at ways to analyze the gas prices across the blockchain. But 67 Gwei is generally a pretty good setting to use. I think by default, if you log into EtherDelta, it'll set it to 4 Gwei, which is much, much less than that. And the gas limit was 41,000, which is good for a regular transfer of funds. I sent 370 bucks worth of ether, 1.6 of it, and it only cost me 32 cents to do that. Now, in comparison, if you were to send $370 in Canada to somebody by the easiest method that the banks give you, which is an Interac e-transfer, you'll generally pay, depending on your bank, $1.50, maybe $4 for that transaction, unless you pay a lot of money, 60 bucks or more a month for an account that gives you free transactions. And really, that's one of the major benefits, is that you don't pay that $1.50 or that $4. So by comparison here, we sent 370 bucks for 32 cents, which is awesome. So I wonder if I'm skipping ahead of myself here. No, we don't need that. We need, I mean, we basically covered this, but we're going to look at some different Etherscan TX, some other people's that we're going to Google to find to see people that beat people in ICOs by setting a ridiculously high gas limit and gas price to get the tokens faster than everybody else. I have a specific one I'm thinking of. I just don't know if I can look it up by Googling it, but we'll find out. So, I mean, that's a good definition of ETH gas, but I wonder how pros define it on the internet. What is ETH gas? Ethereum is the network, also known as the blockchain. Ether is the fuel for that network. When you send tokens, interact with a contract, send ETH, or do anything else on the blockchain, you must pay for that computation. That payment is calculated in gas, and gas is paid in ETH. That's a good one. That's on my Ether wallet. I wonder if we can find a mainstream outlet that'll tell us what it is. Not really. Well, we want to spend 20 minutes in this particular session. We've only been here for 6 minutes. Here's a shapeshift definition. What does out of gas mean? There's different errors that you can get for not having the right amount of gas, or not setting enough gas to interact with a contract. I wonder if I can find one of my addresses that'll tell me about that. Here's a conversation with me and the founder and writer of EtherDelta about using the EtherDelta API. So let's see if I can find some of my failed transactions. And see if we can find some gas errors. Here's some errors. Bad jump destination, bad jump destination, bad jump destination. I wonder if we can find any that are complaining about the gas that I used. How many transactions do we have here? The bad jump destination error basically means that when I was trying to interact with the smart contract, that contract or that order on EtherDelta had already been taken up. Well, I can't find any out of gas errors here, unfortunately. There's another contract that I did interact with that gave me a ton of out of gas errors. Maybe we can just look up the contract and see if anybody else is getting that same kind of error. And that company was called Total. They're a DEX aggregator. Here we go. So other people should be getting the same kind of errors that I was getting. This has been reverted, which means that wasn't accepted by the contract. We want a gas error. Maybe I can just Google examples of ether gas errors. Out of gas. This one is out of gas. So the person was trying to send $11,000 and it didn't go through. It was sent back to that original address. They tried to pay 500 Gwei worth of gas in 1,000 gas limit. It's in interaction with the contracts from Gatecoin. The issue here is that their gas limit wasn't high enough, which means that it took all of the gas to try and complete this transaction before it aired out and said there wasn't enough gas available. So even though they tried to pay 500 Gwei to have this transaction happen, because it hit the gas limit and it couldn't go any farther and spend any more gas, because remember it's a calculation by the gas limit times the gas price here, it canceled out and was out of gas. And if we go back, that's what exactly somebody would have told them here in the Stack Overflow answer. This is a very detailed answer. On either scan, there's no clear indication whether or not gas was sufficient. However, the state's cumulative gas used is equal to the gas limit we set. This is a very strong indicator that the transaction ran out of gas. In theory, it could have indeed used the same exact amount, but this is very unlikely. And I guess this is a different block explorer where we can find out more reasons why you might get a specific answer. So let's have a look. Oh, it doesn't exist anymore. I wonder when that person posted that answer. No, this site does not exist. When was this answer posted? 2016. That's unfortunate. Well, let's go back to our friend that tried to send 50 ETH, which is a whole bunch of ETH. Let's go look at the address and see if he was able to ever successfully send that 50 ETH. This guy's 5,000 transactions. Can I order by the value? No, I can't. We know it was 900 some days ago. Let's find out when exactly that was. 992 days ago. Let's try page 15. Page 32. Page 64. Page 80. 992. Page 85. 992. Page, whoops, where do we go? Page 82. So we're using binary sort now to figure out where this guy sent that 50 ether. There's the 50 ether. He had the out of gas error. He never sent it again at exactly 50 ether, but he did not interact with that contract again either. This guy had a whole bunch of ether. Look at this, 500, 900, 400. Well, let's take a look at one of these bigger transactions. 1,454 ether. So that's $335,000 at 500 Gwei. This one was successful and used all the gas. because it was just to a regular address. But see, this guy paid $2.42 to send over $300,000, and that's one of the major benefits of blockchain, is that you can send a lot of money uh, to anyone around the world, and you only pay a minimum amount of fees to do that. Trying to find another example of different kind of out of gas error you might see, or different gas related error. When you try to do something and try to pay too much gas or not enough gas programmatically using programs that you write, and we've seen this in my other recordings and live streams, on and off. At least this exceeds block gas limit error. Basically, these are other gas errors that you can receive. So if you try to set a gas price, and well, I wonder if we can do it in MetaMask. Let me give you an example. I wonder if we have any Rinkeby ETH. Let's go back to our VM, because I know I have Rinkeby ETH. So I should have Rinkeby ETH in one of these accounts. There we go. So let's try to send it to one of the other accounts using too much gas and see if we get that error. And this also covers, I guess, the next session, which is how to set gas inside of MetaMask. So you set an address, you set an amount. On the next screen, oh, I don't have enough Ether to do that. Oh, whoops, I'm trying to send from that account to that account. So let's go back to account 1. So here on the next screen, you get to set your gas limit and gas price. So if I try to set way too much, it actually tells me right here in MetaMask that we're not able to do that. So let's take a look at a different interface. Let's take a look at one of our contracts we're creating using Truffle. Just so I can show you this error. Because MetaMask is too smart to let you do it. To let you do it and get that error. So if I was to go to my Truffle file and set way too much gas, and also take a look at my deploy, it doesn't say how much gas to use, so it's going to use the Truffle config. Run our Ganache, it's going to launch here in a sec. If I was to use way too much gas, we're just waiting for Ganache now. Here it comes. So if I was to use way too much gas and try to run this contract creation using Truffle using Migrate, it should error out and say exceeds block gas limit, meaning I'm trying to pay too much gas for what this Ether chain or testnet allows, and it also applies to the mainnet. If you try to use too much gas, it'll just error out, or like for instance, we just saw MetaMask won't even let you set too much gas. But we'll see the error here in a sec that the blockchain gives you. Here it is. No, oh, I got a different error because it's way too high. Sorry about that. We'll set it a little bit lower, but still too high. Where am I? This is a truffle specific error. It's a number that's too large for it to understand, which is not the error we were expecting. So let's try it again with 99 million gas limit. Wonder how our stream's doing. Well, thanks everybody for watching, and we'll be streaming all day. There we go, exceeds block gas limits. We tried to pay way too much gas to achieve what we wanted to do. So if we tried to pay not enough gas to achieve what we wanted to do, like a very minimum amount, we should get another error, a third error related to gas that says intrinsic gas too low, which means that the gas price multiplied by the gas limit is much too low to accomplish anything. Hello, live EDU moderator. Note, base fee exceeds gas limit. That's not quite what I was expecting. I think that's a truffle specific error. It's telling me that the base fee that is required to do the action exceeds the gas limit that we set, which is what I've expected to see. Basically, is the error, just different wording. So there's three different kinds of errors: out of gas, gas exceeds block limit, and base fee exceeds the gas limit. That you get to see if you try to interact with ETH using not enough gas, too much gas, and well, not enough gas for out of gas, too much gas for exceeds block limit, and also not enough gas for this third one that we see here. Base fee exceeds the gas limit. Well, that concludes this stream. That's basically the first session here of ETH gas explained. We looked at what ETH gas is, how it's defined, how I defined it once to successfully get a blockchain position that I worked for 6 or 7 months, as well as how it's defined on the internet, the different kinds of errors that we can see when we try to use gas, not enough gas, too much gas, or not enough gas in a different way, programmatically. And next we'll be back here on this live stream in 3 to 5 minutes to look at how to set the gas limit and gas price in Mu and MetaMask. We might look at a couple of different blockchain interfaces, but we'll have that live stream in a few minutes here for the next 20 minutes once we return. All right, thanks everybody, and we will be back. Hello, people of the internet. All right, let's see if that last stream saved, just to be sure. Yep, it did. The very first one, 20 minutes. So let's have a look at our project overview and see what we'll cover next. So we're going to look at how to set the gas limit and gas price on Mu, MetaMask, Ether Delta, other blockchain interfaces. So again, all these interfaces are just different ways to interact with the blockchain. The blockchain exists separately from these interfaces. As MyEtherWallet tells you in detail when you go to visit their site, they don't control the blockchain. MetaMask tells you in detail when you go to use MetaMask that they don't control the blockchain. The blockchain exists on its own, and there's just different ways to access it. So let's take a look at MyEtherWallet. So we're going to get a big old warning that says exactly what I just said. We can actually read through that warning. Take a look. It looks like you didn't finish reading through these slides the last time. Pro tip, finish. Whoops. Finish reading through the slides. Welcome to My Ether Wallet. We know this click-through stuff is annoying. We are sorry. Please take time to understand this is for your own safety. Your funds will be stolen if you do not heed these warnings. We cannot recover your funds or freeze your account if you visit a phishing site or lose your private key. What is Mew? My Ether Wallet is a free, open-source, client-side interface. We allow you to interact directly with the blockchain while remaining in full control of your keys and your funds. You and only you are responsible for your security. My Ether Wallet is not a bank. When you open an account with a bank or exchange, they create an account with you on their system. The bank keeps track of your personal information, account passwords, balances, transactions, and ultimately your money. The bank charges fees to manage your account and provide services like refunding transactions when your card gets stolen. The bank allows you to write a check or charge your debit card to send money, or go online to check your balance, reset your password, and get a new debit card if you lose it. If you have an account with the bank or exchange, they decide how much money you can send, where you can send it, or how long and how long to hold on suspicious deposit, all for a fee that they charge. My Ether Wallet is an interface. When you create an account on My Ether Wallet, you are generating a cryptographic set of numbers, your private key and public key or address. The handling of your keys happens entirely on your computer inside your browser. It doesn't hit a server anywhere. We never transmit, receive, or store your private key, password, or other account information. We do not charge a transaction fee. You are simply using our interface to interact directly with the blockchain. If you send your public key or address to someone, they can send you Ether tokens, which is a good thing. If you send your private key to someone, they now have full control of your account, which is a bad thing. What the fuck is a blockchain? The blockchain is a huge global decentralized spreadsheet. It keeps track of who sent how many coins to whom and what the balance of every account is. It is stored and maintained by thousands of people, who are miners, across the globe who have special computers or hardware. The blocks in the blockchain are made up of all the individual transactions sent from My Ether Wallet, MetaMask, Exodus, Mist, Geth, Parity, and everywhere else. When you see the balance on myetherwallet.com or view your transactions on etherscan.io, you're seeing the data on the blockchain, not on your personal systems. That's a good point. Let's add Etherscan to our list of interfaces that we're looking at. Where are we? Again, we are not a bank. But why? Because you need to understand that we cannot access your account or send you funds for you X, recover or change your private key, recover or reset your password, reverse, cancel, or refund transactions, freeze accounts. You and only you are responsible for your security. Be diligent to keep your private key and password safe. Your private keys is sometimes called your mnemonic phrase, key store file, UTC file, JSON file, or wallet file. If you lose your private key or password, no one can recover it. If you enter your private key on a phishing website, you will have all your funds taken. That's very important to know, and it happens to many, many people. What's the point of Mew then? Because if Ether Wallet can't do those things, what's the point? Because that is the point of decentralization and the blockchain. You don't have to rely on your bank, government, or anyone else when you want to move your funds. You don't have to rely on the security of an exchange or bank to keep your funds safe. If you don't find these things valuable, ask yourself why you think the blockchain and the cryptocurrencies are valuable. If you don't like the sound of this, consider using Coinbase or blockchain.info. They have more familiar accounts and with usernames and passwords. If you are scared but want to use Mew, get a hardware wallet. These keep your keys secure. How to protect yourself and your funds. Basically, it goes on to tell you that you need to make sure you're always using the right directly to a site before you enter information. Do not enter information after clicking a link in a message or an email. Install an ad blocker and do not click on ads in your search engine like Google. How to protect yourself from scams. If it is too good to be true, it probably is. There's a good motto for anybody thinking about doing anything. Research before sending money to someone else or some project. Look for information on a variety of websites and forums, and be wary. Ask questions when you don't understand something or it doesn't seem right. Don't let fear, FUD, or FOMO, which is fear, uncertainty, and doubt, and I'm not sure what FOMO means, win over common sense. It's the good kind of FUD, though. It's the other side. It's the opposite one. If something is very urgent, ask yourself why. It may be to create FOMO or prevent you from doing research. How to protect yourself from loss. Make a backup of your private key. Store this paper or USB drive backup. Do not store your private key in Dropbox, Google Drive, or anywhere else. If you have any more than one week's worth of cryptocurrency, get a hardware wallet. No excuses. It was worth it. I promise. One more click and you're done. Here's some links to get a hardware wallet and a whole bunch of other stuff. Learn more or contact us. Oh my God, please let me send FFS. Done. Well, I guess now we've clicked through all the warnings that I just mentioned would be there that tell you exactly what I told you, which is these are just different interfaces for the blockchain and don't actually represent the blockchain or control the blockchain. So if I was to send Ether in tokens, we can actually see the gas prices set up here universally across all of my Ether wallet. So it tells you how fast it might be. We're going to look at how to analyze the blockchain and see how fast it will be when you set whatever gas price and gas limit. But it's maybe fast, really, really slow, or fast. And the slider goes from all the way from 1 to about 50 on maybe fast, and 99 Gwei on fast. Now you can't set it any higher than that because my Ether wallet is an interface and it only lets you set what it lets you set here. If you were using a different interface like MetaMask, which we'll see in a second, you'll be able to set a higher than 99 Gwei gas price, which is very helpful if you're trying to beat other people in a race to get tokens at an ICO or whatever you're trying to achieve that you have to do faster than everybody else that's doing it at the exact same time. So we'll set it at 50 Gwei. We'll go to send Ether in tokens. What did I break here? So you got to unlock your account first. So we'll just get a private key here to unlock with. Can you unlock using MetaMask? You super can. Connect to MetaMask. There we go. So we unlock my account. It's got 0 ETH on my localhost. On my localhost network. We could actually use a different MyEther or MetaMask. We could import one of my Ganonche addresses just so we have some Ether to send. I wanted to import account, sorry. Put the private key in there. We're on the wrong testnet on our MetaMask. I'll put in a semicolon instead of a colon. So my Ether wallet is now reloading. We should see a balance of 100 Ether. If I unlock using MetaMask. Here we have 100 Ether. So if I was to send this to a different account, send an Ether, we can now set the gas limit, which is the other part of the gas equation. So with a lower gas limit, like this recommended one to send some Ether, we could go ahead and generate this transaction and send it, and it will send and it will confirm in a short amount of time, especially on my local testnet. But if we set a higher amount, lower than too high, we'll be able to send it much, much faster. So the equation is the gas price times the gas limit is how much gas could be spent if it uses all of it. So if I generate this transaction and send it, using my Ether wallet connected to MetaMask, we're going to hit 2 birds with 1 stone here, because it's going to confirm how much I want to spend, which is 50 Gwei in this many units of gas limit. If I submit that transaction, I could change it here actually and spend more Gwei on my gas price. This is how much it would cost if we were using real Ether, the max transaction fee, which it probably won't use the max, it'll probably use some portion of it to complete this transaction. If I submit that and then watch it in Ganonche, we'll see that it actually only used 2100 gas, 21,000 gas, which is what it recommended that it should use for a transaction. Now, if you're interacting with a contract, like to buy tokens or to do anything else with a contract, it would use far more gas because it's got to do more computations and you got to pay more to the miners to complete that. So let's take a look at some other interfaces to the blockchain. So we've already seen my Ether wallet and MetaMask. We're about 11 minutes through this video. We want it to last about 20 minutes on the live stream. Let's check out how the live stream is doing. Hello, live EDU moderator. Well, let's take a look at Ether Delta. Hello to all my 14 viewers. Everybody give me a subscribe. So here on Ether Delta, it's probably going to complain that we're not on the main net. Now there's a couple different ways we can use Ether Delta. We can use Ether Delta using MetaMask, which it defaults to if you have MetaMask on and unlocked. So it complains that we're not using the mainnet, but that's fine. So if I go to, I think, contract, account, I can set the gas price. And the default is 4. So the default is really, really low. So if you're trying to beat somebody to an order on Ether Delta, if you use the default of 4 Gwei, it's probably not going to happen that fast. You could use the maximum on my Ether wallet, like 99, or you could even go for a much higher gas price if you wanted to be much, much faster than anybody else trying to execute on the same order. So that's very, very important. If you were to try to find an order that's at such a good price that everybody else is going to buy it. Like we can see here that this price for this 0.008 Ether worth of PPT token is actually set at just above what it costs to buy it. So if we were to try to sell it rather. So you can see it's a much better price than the next order on the book, which takes up a lot more volume. And so somebody's probably already beaten us to this order, which we can't even execute because we're not on the mainnet. Let's try. Oh, look at that. You cannot trade this order because it has already been traded. Somebody beat us to it, and it's not even on the order books anymore because it was such a good order. Meaning that that person who traded it, if we can find it over here. It was traded so recently it's not even in the trade list. But I bet you if somebody paid a ton of gas to get that price. I wonder if we can find another order for somebody that paid a good price and check it out on Etherscan. This person, he was using the default of 4 Gwei and only paid 9 cents for his transaction, which he got 0.399 Ether worth of tokens. This guy got 25, or rather, of PPT. How much is PPT worth? Not that much. Let's find somebody who bought a whole bunch of them and see how much gas they paid. All these tiny transactions. This person bought and then immediately sold 436 worth. I wonder if that was an arbitrage move 7 days ago. This person paid a ton of Gwei, 53, to make sure that his was executed faster than everybody else that tried to execute on that order that existed. That was at a good price to make a little bit of money. So if I understand this correctly, he bought 436 for 0.0 at 0.0131, and then no, at 129 rather, and then sold it at 131. Unless he sold for a loss, I'm not sure. I'm not sure what the green and red means here. But that's how you can set your gas price, and your gas limit you can set when you go to verify your transaction with MetaMask. I'm not sure this is going to work because we're not on the mainnet. Nope, somebody already traded that order too. Let's just go on the mainnet and see if that helps. So once you hit buy here, it's going to pop up with a MetaMask confirmation. And in that MetaMask confirmation, you can set a higher gas price. I don't have any funds to do it with though on the mainnet. Let's go back to our test net and see if I'm able to do a test transaction. I don't know if I'm able to or not. I've never tried using a test net on Ether Delta. Somebody's asking if it's a decentralized exchange. Oh, it's still going to complain I don't have funds because I didn't deposit any. I tried to deposit some on Ether Delta using my testnet in a previous live stream, and it didn't deposit, obviously because the contract doesn't exist on my testnet. So it's just going to give us the same error here. Yep, you don't have funds. Either way, it would pop up with a confirmation, a MetaMask confirmation that says, "Are you sure you want to do this?" and ask you how much of a gas limit you want to spend. I wonder if I can find a different interface like ETHLend, or actually, I think ETHFinex will let us do it, which is a decentralized exchange, centralized and decentralized. Let's use either centralized, or it says Go Trustless here, which is the decentralized aspect of it. And again, it's just another interface to the blockchain, specifically for trading tokens. It says connect to the mainnet network. It's probably not going to let me see the MetaMask confirmation for a transaction, unfortunately. Um, I wonder how we can get one to pop up. So apparently we can use a demo of ETHLend on Coven testnet. So let's just change that testnet now. Here's a MetaMask confirmation. So we're trying to send I think a signed transaction to ETHLend, and we get to set our gas limit, which is set a whole bunch of gas here, and 3 Gwei it suggests. So we could actually set that much higher, and obviously we have insufficient balance because we have no balance. What they suggest here would cost up to $2.77. And I'm pretty sure this is just signing the message that says that we want to use ETHLend, and then we get to go through their process later. But again, it's just another interface to the blockchain, and that's how you set the gas price and gas limit. On Ether Delta, that pop-up would have popped up. You would have been able to change the gas limit rather, and the gas price, but it would use whichever default you have. That said, on Ether Delta, you don't have to use MetaMask because you can use an account you create or import. In which case it just uses the default, come on now. Account. So if I do new account, it's just going to generate me an account on the blockchain, and give me the private key, hopefully, here in a sec. Come on, Ether Delta. Try that again. New account. There we go. It gives me the private key. It tells me to back it up. And here's my Ether account that I just created, which is currently empty. But now if I go to do a transaction on EtherDelta, it's going to use the GUI that we set as gas price here on the setting for gas price, and then it's going to use the default gas limit, whatever that sets it to when it tries to do something on EtherDelta. So you have more control with MetaMask because you're able to modify the gas limit and pay a different gas. So that concludes this section of this session. This session rather, in how to explain the gas. We just covered how to set the gas limit and gas price on Mu, MetaMask, EtherDelta. We didn't actually look at EtherScan, but you can on EtherScan. And we didn't really look. And other blockchain interfaces I'll leave in there because we touched on ETHFinex, ETHLend, and we will be back in 3 to 5 minutes. We're going to go with the next session, which is how to look through old EtherScan transactions, and we'll hopefully look at some that happened during an ICO period where it was very important for people to have much better gas limit and gas price to pay more gas, sometimes thousands of dollars worth of gas, which we'll see, in order to get their transactions in sooner and eat up all those tokens. But that's it for now, and we'll be back in just a few minutes. Thanks, everybody, and give me a follow, give me a subscribe.
Hello, people of the internet. Hello, Neha9029 for joining the room. Congratulations on joining. I'm glad to have you. If you want to chat me up, I'll be watching the chat here as I'm using my virtual machine in a little tiny window when I'm doing stuff on the stream. Speaking of doing stuff on the stream, we're going to look at the next session, which is how to look to some old EtherScan transactions to find ones where people paid an exorbitant amount of gas to be faster than other people. So let's take a look. I wonder if I can find the one that I'm thinking of. Probably, if I figure out what I'm trying to find out here. Nope, that's the wrong one. So somewhere in here, in some of the first transactions, somebody's paid. So what happened during the Fort Knoxer sale is that on the first day of the sale, they had a capped amount that people can send. And this is not the right contract that I'm looking for. I wonder if I can find what I'm looking for. I want the crowdfunding address. Actually, they had individual addresses to use, so I wonder if I can just Google the... No, I can't find the one I'm looking for.
Here's the guy who holds the most. Nope, it's not the one we're looking for. They bought $3 million worth of tokens, and I want to find that transaction because they spent about $2,000 on it. This is IDEX, is that what we're looking for? Well, let's just Google examples of people paying loads of gas in ICOs. Well, actually, we could skip ahead a section and look at ETH gas tracker because they have a section on their site that shows us people that spend a lot in gas. So let's see why these people are paying a lot of gas. This one has a lot of pending transactions. It's a contract. We want to find a person that's not a contract. Hello, H3CKM3. How are you? This is a contract. This is a contract. These are all contracts. I want to find somebody who's just spent a lot of gas. Contract. 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 We're looking for an address. Let's try the bottom of the list. Contract. 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 Jeez almighty. Maybe there's another way we can find an example, because this is not working. So the top gas burner here is a contract. It's using 5% of all gas in the network. So that means it's probably an ICO that's live right now, I'd imagine. So let's see if we can find transactions that have confirmed and see if people are having a gas war to pay enough gas to get in this ICO. That's what I assume is happening. Nope, not the case. People are doing 0 Ether transactions. Even on the last page, they're doing 0 Ether transactions. But they're paying $5 per transaction. I wonder if we can find an example that has a lot of gas here. Let's go back to our Fort Knox, for example, and look at some of the first transactions and see if we can find any that have a ton of gas. It's the wrong one again. No, because this isn't the crowd sale. Example, crowd sale, Ether scan. Somebody maliciously posted a private key on ICX's ETHplorer comments. It has a whole bunch of ICX, and people are just scamming ETH that way. But let's see if this guy paid an exorbitant amount of gas, because that's what we're trying to find, to acquire those ICX. I just happen to know this private key exists. There's no way to get the ICX out unless they're gone now and somebody successfully got them out. I have no idea. Let's find out. So we need the public key to look up the address on Etherscan. So they still had $50,000 worth of tokens, which is 75,000 ICX basically, and a couple other tokens in here that are still left over. Somebody gave them 75 billion or whatever tokens at some point. But here's the ICX tokens. So what we really want to find out is the original transaction that bought ICX. A whole lot of Decentraland. 75,000 Icon. So that was 383 days ago that he received them. So let's go back, see how much he paid for them and how much gas he paid. Um, $383 days ago. $102 Ether, you suppose that's it? He paid 280 Gwei at 300,000 gas limit. He only ended up paying 21,000 for that transaction. It only cost $1.35. No, that's an example of a low transaction fee. Just export all these transactions. This holder of CryptoKitties that we found.
Come on, Google Drive.
Could swear it's been 700 degrees in here since you came in. I could swear that this room has been running out of air, and now it's starting to spin. You make me feel kind of bad, kind of good, kind of everything, yet it doesn't feel like it should. You make me feel kind of wrong, kind of right, kind of anything, and I would change it if I could.
No, this guy only spent at most $1.50 on transactions in US dollars out of the thousands that we exported. He spent $460 in transactions total since January 1st, 2018, and the average is 23 cents, which means that he moved $17,000 Ether for only $600. No, $17,000 worth of, is that? Yeah, at $229 in ETH. At the historical prices, what it was at the time, no, we gotta multiply that by, let's find out exactly how many ETH he sent at the historical value. Hello, live video moderator.
Ain't no telling what we gon' do. Yeah, I've been feeling good lately, and it feels good to feel good again. Yeah, look, I wanna treat you like a 90s R&B song. No, it's only been a month, but I don't think we need long. Cause you got me out of my comfort zone, feeling comfortable in deep water cause of shallow feelings and undertows. See, I don't usually fall this fast, but you will make me call my last until I lose my number. Ain't worried about a title, but hope you don't choose another. Yeah, I'm in over my head, but something about you in the city makes me hope for the best. But fuck it, dog, I'm 23 with the world on a string, getting paid for every word that I sing. I earned everything, been working, and now I'm paying rent with my passion. GQ sending checks when I know nothing about fashion. I swear there's something you lack and that I know how to supply. We ain't even gotta talk, I see it all in your eyes. So don't you worry that I'm worried when you read in the mood. Said I'm just happy that I'm back to really feeling this good, I swear. Ain't no telling what we gon' do. I'm just trying to
Nearly done copying these fields over. Here we go. So at the historical value of ETH at the time, since January 1st, 2018, this guy's sent $18.5 million worth of ETH. And again, he's only paid a total in transactions of $460 for that, which is outstanding. So I didn't get to see my original point that I wanted to make. Hello, live video moderator. Importance of ETH and blockchain in reducing fees globally.
All right, well, that concludes this section of the live stream, which is looking at how if we changed it, I guess, halfway through, because I couldn't find any good examples of people paying thousands of dollars in ETH and gas. But we changed the goal to see how ETH in other blockchains transaction fees are much lower than the banks. So if this guy wanted to send $18.5 million in banks with bank money, with money in the bank, he would have spent a whole bunch of money on fees that he otherwise wouldn't have to if he's using blockchain, and he also probably would have seen some prohibitive actions taken by the government or by the banks or by the police that would hold up his funds and take many weeks to transfer that whole amount or those multiple amounts that he was trying to send, which is good. So I guess that concludes this session. We'll come back next with looking at ETH gas station and the different things we can do with ETH gas station. All right, thanks guys, and I'll be back in. Hello, people of the internet. How are you doing? Hello, people. I can hear myself. That's not good. Means you can hear me, which is good. So here we are in our next session of ETH gas and what it is and how to think about it. The next session we're going to look at ETH gas station, what it is, how to use it, what information is on what pages. We already looked at one of the pages in some detail, but we'll look at the other pages now. So let's take a look. Let's close out of some of these sites that we don't need. Now I think I've made up my mind to only do half of this live stream today, which is 2.5 hours. So we're already about 1 hour, just over 1 hour in. So let's take a look at it. Gas tracker ETH. So in this first session, we're going to look at what's on the landing page. It's ETH gas station, actually, that we're looking for. And we got some music, which is good. So here on the landing page, let's zoom out a little bit. So we have the standard no, it's not sexually transmitted disease that we're after. I think it's the standard deviation, guys, or at least the mean that we're looking at, which is the average. So the average cost for transfer in the last little while has been just over a penny. The average gas price that was paid is 2.3 gwei. Remember, we were looking at it before, and we were paying exorbitant amounts of gwei, or we found some people that paid hundreds of gwei to get a transaction through. The average one really right now is 2.3, which is not that much. It goes up when there's times of huge usage of the blockchain. So if there's an ICO that was currently running, the average would be much higher. It says the safe low cost for transaction, if you were to send a transaction, would be a penny. That means that you could still send it through within a reasonable amount of time, but it would only cost you a penny, which would be 2.1 gwei if you were to set it in gwei. The median wait in seconds is 27 seconds to see your transaction confirmed, and that's about 2 blocks, meaning that the blockchain right now is not that congested. So here's an estimator. We can change the gas limit here. If we want the longest confirmation time that it could possibly take, it would take an average of 228 minutes. How does this work? Well, there's a better way to estimate in one of the next sessions that we're going to go over. I can't seem to understand why we can't change this. So we'll just ignore that for now, I guess. Is there an error on my console? Yeah, something's not working. Let's try this in incognito. No, it's just broken in general. That's no good. So here's the transaction count by gas price, meaning how much people are paying in gas price. So more than 50, between 20 and 50, between 4 and 20, between 1 and 4, and less than 1. Here's how many transactions are on the blockchain right now. There's about nearly 50 transactions that are in the median price here, the middle price of between 4 and 20. There's a couple that are above 50. I can't really see this graph or interact with it properly. It's like this is not working at all. It's not letting me hover over stuff. Oh well, that's what that graph shows you. The confirmation time by gas price. If you pay 1 gas, it's going to take you 4 minutes. If you pay 2 gas, it's going to take you 2.5 minutes. We'll see a better layout of how this looks in the future when we look at a different page here on ETH gas station. Here's recommended gas prices based on the current network conditions. So if you were to send something in less than 30 minutes, you pay 2.1 Gwei. If you want to send something in less than 5 minutes, you pay 2.3 Gwei. And if you want to send something almost immediately in less than 2 minutes, you want to pay 20 Gwei. And it's just got a note here that says that estimates are not valid if you're using the same address. So you might want to use a higher Gwei for an address that has a whole bunch of pending transactions. This is showing you who's mining the blocks that are giving the transactions that are put through on the blockchain over the last number of blocks. So you see different mining conglomerates like Ethermine and Nanopool are solving many of the blocks, and the average gas price that's paid to get through on those different miners or groups of miners. Here's some miscellaneous stats over the last 1,500 blocks. Somebody actually paid 0 Gwei to get a transaction through. Somebody paid 1,400 and... Oh, here we can find a transaction where somebody paid a whole bunch of Gwei. Yay! So that kind of ties in with our last session where we weren't able to find something like this. So this person paid $68 to send $160, which is probably a mistake. The median price, the average price paid, is 5 Gwei. The cheapest transfer was less than 0.2 of a penny, just around 0.2 of a penny. The highest transaction fee was the guy we just looked at, the $68 one. And there's been 106,000 transactions over the last 1,500 blocks, which is about 750 minutes. There's been empty blocks and full blocks. And you can tip this site some ETH. Oh, it actually opens up MetaMask automatically when you click on the address. That's pretty cool. I wonder how much this site has been tipped. So these people have been tipped 602 times, sometimes as little as 0.002 Ether. That's probably the recommended amount of Ether that came up when we clicked on this tip button. Oh, it's the actual standard amount. We can't even change the amount that we want to tip. I wonder if some people have tipped more than once. No, not really. But you can see here how you can make a whole bunch of Ether. There's only $55 worth there right now. Somebody's giving me some tokens here, probably as promotions. I wonder how much they've withdrawn whenever they withdraw a transaction or make a withdrawal from their tip address. So they withdrew 0.07 Ether at one point. So they made a good $17 right there on that transaction, which is pretty good. All right, we've only been on for 8 minutes. We want to kind of talk a little bit more about this landing page. So let's see if we can get this estimator to work. I wonder if we can get it to work in a different browser.
So we still can't use this estimator. I wonder if we look at the top miner here, the one that has the most of the total blocks in the last little while, and see how much money's been put through that address. Mined over 1 million blocks. Currently has $213,000 worth of ether on it, 930. And 15 million transactions. People have actually sent tokens to this address for no apparent reason, probably just promotion. Or by mistake. So within the last minute, there's been more than 50 transactions from Ethermine to different people that are mining using that pool. That's pretty cool. Yeah, well, in summary, what we just looked over there is the landing page of ETH gas station. And what we'll look over next here is the next page on ETH gas station, which is going to be the TX calculator and how we use that. All right, so everybody that's watching, we have 18 viewers. That's awesome. I'm glad to see everybody here, and we will be back in the next few minutes. Hello, people of the internet, and welcome to this next session of ETH gas and how to figure out what ETH gas is and how to use it and how to measure it and how to look at it on the blockchain. So the next session that we're looking at here is the next page on the ETH gas station site, which is the TX calculator, and we're going to figure out how to use that together. Alright, so let's take a look. This next page of ETH gas station. So, I mean, we actually saw on the main page that there was a calculator that didn't even work. This gas time price estimator doesn't allow us. Oh, it's working now. I have no idea why. That's pretty good then. So it's saying the minimum gas price you want to pay is 2.5 for an average confirmation time of 1.64 minutes. And if you're not very lucky, the most time it should take you, or 95% of the people paying 2.5 gas price at 21,000 gas used, will be 4 minutes. So we can actually adjust this up. At 4 GWI used, and this is what we'll see in the TX calculator. We're just able to enter in the amounts. We'll see that it's 3 minutes that you're going to be waiting probably at max, and 1.01 minutes to confirm on average. If you pay a whole bunch of GWI, it only lets you go to 16.7 GWI. We could actually change this gas used to a little bit higher, 41,000 gas used. It's going to take an average of less than a minute and at most probably 2 minutes. But that's probably what it tells us here on this next page that we're looking at right now, which is the TX calculator. So if you use the base rate, the standard rate to send a transaction of gas limit, which is 21,000, and then you wanted to use a gas price of an average amount or a cheap amount, which is right now the same at 2 GWI because the blockchain isn't very busy, and submit that. 37% of the last 200 blocks would accept this gas price, which means it would take you an average of 3 blocks to get there, or 2 blocks. Transaction at or above this in the current transaction pool, so people that are paying this amount or more, is 257, just waiting to be and pending to be completed right now. It'll take you about 104 blocks to be confirmed, which is 1,489 seconds, and it'll cost you under a penny, just under a penny. If you want to use the fastest that it recommends, which is 80 GWI, you'll see that most of the blocks, it'll take you less than a block to get accepted, which it should tell us here somewhere. Mean time to confirm in blocks is 2.
There's only one person that's paid more than this in the current transaction pool, and this would cost you 38 cents. That's the max that it recommends. If you were to put in a ridiculous amount, you'll see that it doesn't even change the calculations. It just tells you it'll take about 29 seconds to confirm and cost you 38 cents, because it's not going to use any more GUI than it has to, or any more gas than it has to confirm. So if the blockchain isn't busy, it's only going to max out at whatever amount is going to get you there the absolute fastest, which in our case is 38 cents. So if the blockchain is busier, you can spend more to get more done. Well, unfortunately, that only took us 4 minutes to do. So let's combine these two sessions and look at the TX Pool Vision page. So here's the block that we're at. Gas price. How many of the last 200 blocks are going to accept that in a percentage? Percentage of the total transaction mined in the last 200 blocks that are using that GUI price. So how many other people are paying that much GUI? You can see down here it gets to be much, much higher. So there's 50% that have paid 3.2 or better. Transactions at or above that amount in the transaction pool, there's 4,822 above 1 GUI. If we take a look at 4 GUI again, you'll see there's only 132 ahead of you. Median age in blocks, so that's how long it should take you in the amount of blocks to get there. You see it varies based on the different transactions that are actually on the blockchain using higher gas price. Last seen in 5 minutes, percent mined in 5 minutes, and percent of transaction unmined in 5 minutes. So you see, if you pay 1.5 GUI or less, there's a good chance that your transaction won't be mined in 5 minutes. There really aren't even that many people paying 1 GUI. There's only been one in the last 5 minutes. There's been 382 of 1.1 GUI or less. No, 1.1 GUI exactly. And 45% of them haven't seen their transaction mined within 5 minutes. So what I normally do is I come to this site, ETH gas station. I take a look at this table to see what the current state of the blockchain is, see how many transactions are going through at what GUI price, or gas price, and I try to make a decision based on that of what amount of GUI I want to pay in order to see my transaction mined relatively quickly. So if we take a look here, if you pay 4.1 GUI, you're going to see that there's less than 100 transactions ahead of you, and it should take you only 2 blocks to get your transaction mined on the blockchain. Now this table changes all the time based on the current blockchain status and who all is doing what on the blockchain and how many transactions there are in total. And it maxes out at 230 GUI. Nobody's been paying 230 GUI. There's been one person who paid 180 GUI within the last 5 minutes. So I guess that still doesn't get us to 10 minutes. Let's take a look here at our live stream. Thank you to all my 5 viewers right now. I'm very happy that you're here. Let's take a look here. Let's next look at the gas burners that are on the next page of ETH gas station. And again, ETH gas station just scans the blockchain and tells you what's going on at any point in time. So we click on the gas burners link. And we'll see here that over the last 5,000 blocks, again, we looked at all of these, or a bunch of these, from the bottom up and then from the top up to see if we could find any addresses that are spending a whole bunch of gas. But we could only find contracts that are spending a whole bunch of gas. So if we take a look at the top gas burner, we'll see that it's a contract. It's got more than 25 pending transactions that are all trying to pay gas right now. There's 248 pending transactions on this address, and they're all trying to pay gas. The amount they're paying isn't very much, but because there's so many of them,
There's even some failing, a whole bunch failing. There's a whole bunch successful. So the successful ones are only paying 0.0001 ether, 0.0009 ether, which is not that much. So cumulatively, all these together, there's been 50 in the last 39 minutes. They're only paying 21 cents a piece, or not very much in gas. This is actually CryptoKitties contract. So if we take a look at Ether Delta, no, that's the wrong Ether Delta contract. We can see again there's more than 25 pending transactions. There's 27 in total right now. And out of the ones that have completed, out of the millions and millions that have completed over time, we can see there's been 38 in the last 38 minutes rather for the last 25 transactions, or 50 I think. Yep, 50. So there's been more than one transaction every minute, and these people are not paying very much in fees. Looks like the most we see here is 0.0015, and that actually failed. Somebody tried to pay a whole bunch of gas and was beaten to an order that somebody else already got, and that gives us the bad jump destination error. This guy paid 34 cents to get their ether refunded to them. And that basically concludes this session, which wrapped up how to look at ETH gas station. And next we'll be looking at Bitcoin fees, starting with why Bitcoin fees are becoming prohibitively high. And we'll take a look at that and see if we can find some articles on the internet that go over that fact and see if we can figure out why that's happening. And then in the next few sessions we'll look at what solutions exist to offset the high Bitcoin transaction fees, and who benefits from high transaction fees on a particular network, including Bitcoin. As we all know, if we're crypto enthusiasts, we probably have some Bitcoin, and we've probably been trying to move it around in the last half year or so, and been finding that services and transaction fees have been as much as $50 just to make one single transaction. For instance, if you had funds on, well, we'll get into that in the next session either way. So we're done this particular session, and we will be back in just a few minutes. Thank you. Hello, people of the internet. How are you doing? Let's take a look at our stream. Oh, are we streaming? Oh, people of the internet. Here we are. Well, welcome back to the stream, where we're going to go over some more stuff about Bitcoin, or rather blockchain fees, and we're going to talk specifically about Bitcoin fees and see why they've been so high lately. See if we can find some examples of that. Well, I guess they've been down recently. But in June 2018, they were very high. And Exodus is a wallet that's going to give us an explanation as to why. Bitcoin fees charged in Exodus wallet are something that not everyone can understand at first, so we've written an extensive article to explain in details how they are formed. The Bitcoin network calculates fees based on the number of transactions and the size in bytes of each transaction. The size of a transaction depends on the number of inputs and that hold funds. The more inputs you have, the more expensive the transaction. What that means basically is if you have a Bitcoin transaction on the network, sometimes they're combined with other transactions, so you have more than one input, more than one address putting Bitcoin into that transaction where it goes to other addresses. Please note that the fees are not based on the amount of Bitcoin involved in the transaction, as many Bitcoin users are confused about this. One of the easiest ways to think about this is with change in dollars. $1 is the same as 100 pennies. However, it requires more work to count 100 pennies and give it to someone for payment than it does to hand over a $1 bill. This is similar to the Bitcoin network. Let's look at an example. Alice receives 0.01 Bitcoins every day from her mining contract for 100 days. Bob receives a payment of 1 Bitcoin once. Both Alice and Bob now have a 1 Bitcoin balance. If Alice and Bob now try to send 1 Bitcoin, Alice will have a much larger fee than Bob. This is because the Bitcoin network has a lot more work for Alice to bundle all of her small change inputs together compared to Bob, who is just 1 input. This is similar to everyone who tries to spend 100 pennies versus a $1 bill. Both amounts have the same value, but the 100 pennies take longer to count, so it is harder to make the transaction. If you receive small payments over time from a mining contract, you're collecting pennies, essentially. When you send these dozens of small inputs as one payout, the Bitcoin network requires these inputs to be smushed together and batched into one payment. The fees on these transactions are far higher than those with sending more reasonable 1 to 3 input transactions. We have seen fees as high as $50 to $200 for mining contract payouts that have gone on for years. In a few cases, the fee required to send your Bitcoin is higher than your Bitcoin balance. Because of this, we advise users to either receive larger payouts less frequently or receive their payouts in an asset like Ethereum, which we're actually going to look at in the next session, which does not use the same UTXO-based system as Bitcoin or Litecoin, and thus will not have an exorbitant mining fees because of it. Example case. The following is an example of a customer paying $16 in fees. You can see it here in this transaction. The fee is located under inputs and outputs. Now the reason why this customer was charged this much is twofold. Number one, they had many inputs, which we'll see in this screenshot and when we look at the actual transaction. And the Bitcoin network charges a fee per byte, and every input is about 152 bytes. If the Bitcoin network charges a fee per byte and the price for each byte is 210 satoshis at the time of the transaction, this roughly translates to 1.2 cents per byte. The total bytes for this transaction was 1369. You can see this under summary. So if we multiply those values, we get $16.41 in network fees. If you are receiving mining deposits, let's look at this transaction now. It doesn't look like the one that he's talking about. Because I only see 3 transactions, or inputs. Looks like they linked the wrong transaction. If you're receiving mining deposits, each deposit creates 152 bytes worth of input, so we would recommend using a wallet that supports fee customization to receive low volume payouts like this. That way you can reduce but not eliminate the fees needed to consolidate the mining deposit inputs. Electrum is an excellent option for doing this. You may also consider using the wallet service at blockchain.info. Note that you can always see the network fee that you will be charged before completing any transaction in Exodus, which is just specific to Exodus. It tells you the fees here at the bottom of the send screen. Here's an example. If you have any questions, feel free to contact us. So let's change our description here in our live stream.
Let's pray. There is more than we know as the countryside clears and the city's full of the world. The world is yours. Let's pray. It doesn't bring
So let's take a look at why it went down.
people who woke and there was unusual fears of the world. The world is yours.
So it was $26 and now it's down to $3. The average cost of sending a Bitcoin transaction is cheaper than it's been in a year and a half, showing the price isn't the cryptocurrency's only unpredictable metric these days. But with all the debate about growing fees, this might come as a surprise. After all, it wasn't so long ago that fees were so high, a group of prominent investors and miners created a whole new version of Bitcoin, mostly to keep fees lower. Backing up a bit, much of the conflict centered on the fact that while called fees, these expenses are best considered as transaction costs that are necessary to the network, as necessary as paying for someone to deliver a protocol service, be it SMS, VoIP, or email, or even a pizza.
This is because Bitcoin is a software that requires all of the many thousands of computers that run to stay in sync. To do so easily, there's a limit on how much data the network can process at intervals, and users need to pay more to get their transactions in a time of congestion. So that's our answer there. The Bitcoin network was congested, and that's why it cost so much. So as Bitcoin grew more popular in the last year, fees skyrocketed to over $25, according to a graph of data from a website, BitInfoCharts. Bitcoin users, those who truly rely on the protocol for essentials, have been affected by this, as were those who believe Bitcoin could be competitive with legacy payment systems. But Bitcoin fees have fizzled out, declining since the end of December. Here's a graph. So why did fees take the nosedive? The simple answer is users are making fewer transactions right now. In December, there were roughly 400,000 transactions per day, while today Bitcoin is seeing only 200,000, according to the data from blockchain.info. I think it's really simple, BitGo CEO Mike Belch told CoinDesk. There's substantially less transaction demand. The question, he added, is why has there been a decrease in transactions? SegWit and beyond. If Twitter and Reddit are any indication, sentiment on the matter tends to be influenced by personal politics. In this case, where users stand in Bitcoin's long-standing block size debate, which at its core was about network economics. Popular Twitter figure Armand von Bitcoin cheered that the low fees mean the scaling debates are now a thing of the past, pinning the development partly on growing adoption of segregated witness, a scaling feature at the center of Bitcoin's long-raging fee debate. And there is truth to the claims. SegWit was just segregated witness was just a fork in the blockchain chain that happened to help the fees, and SegWit reduces transaction fees and adds more space to the blockchain, but it still isn't widely adopted, so it's hard to say how much actually helped. There hasn't been much of a recent increase in SegWit use either. For the past several months, only about 10 to 14% of transactions, according to SegWit tracking site SegWit Party. Plus, SegWit doesn't reduce the number of transactions, it makes each one cheaper. Another possibility, according to Belch, is that fee prices finally force some larger transaction processors to implement a technology called batching, rolling many transactions into one to leave more space on the blockchain. Indeed, exchanges like Coinbase have said they've worked on implementing this feature in the past. And Thursday, whenever this article was written, cryptocurrency exchange Shapeshift announced that it now batches transactions, making a point that it makes up 2% of all transfers that occur on the Bitcoin blockchain, which is tremendous. However, it's a theory that's difficult to get hard data on unless an exchange were to formally announce that they were using this technique. This is hard to confirm with 100% certainty, Wells said. Still, he argued that even if one large exchange started batching transactions, it could have a huge impact on the overall transaction load. These sorts of technical theories add to the idea that developers and those building services on top of Bitcoin can make optimizations in order to free up space on the blockchain without compromising some of its core features. This is why Bitcoin Core works so hard to get the layer 2 transactions working, and why they focus on so much on optimization of the size of transaction through various things like Schnorr and bulletproofs, Exomedia CEO John Carhall said, adding, they are doing everything to minimize the footprint of every type of transaction attached to Bitcoin because they are all stored forever. Ditching Bitcoin. Others, especially, and this is actually our next session, but we can roll it all into one. Others, especially those critical of how Bitcoin developers favor a smaller blockchain and limited transaction space, argue the lower fees are a consequence of people that are sick of and tired of the high fees of Bitcoin. Bitcoin isn't useful for anything that involves low fees, so people are migrating to alternatives. This has consequences of lowering the fees on Bitcoin, said Ryan X. Charles, founder of Yours, a media startup building on Bitcoin Cash. Charles notably moved his startup off of the Bitcoin blockchain last year, migrating to alternatives before building on Bitcoin Cash. It's possible that some users are doing the same. Payment processor Stripe stopped accepting Bitcoin in January payments due to the high fees, and BitPay, a startup that offers a payment services over Bitcoin, has differentiated into supporting multiple protocols for its merchants. Yet, if they're pushing users elsewhere, it's not clear where they're going. Bitcoin Cash, the cryptocurrency created as a cheaper alternative to Bitcoin, still has about 10% of the number of transactions that Bitcoin currently does. Apparently, high fees don't incentivize folks to switch to Bcash, BitGo engineer Jamison Lopp said.
Bitcoin developer Manny Rosenfeld doesn't think so either. In fact, he disagrees with both of the above theories. The main reason for the drop in Bitcoin transaction fees is not SegWit adoption, and it's not people moving to Bitcoin Cash. It's simply that the craze for buying cryptocurrencies in general has calmed down, he tweeted. Indeed, there's been a downtick in outside interest in Bitcoin. A lower price has less new investors searching for Bitcoin in Google and coming in to buy and trade the cryptocurrency. This view seems supported by the fact that the second most valuable blockchain by market cap, Ethereum, has also seen a dramatic drop in fees in recent months. The same goes for Litecoin, clocking in at number 5, and XRP at third place. Charles has also argued that it's possible Bitcoin's waning hype cycle has contributed to lower fees. I wouldn't be surprised if Ethereum is also lower due to the decline in market value, Charles said, adding, there may simply be less demand for descending transactions across all blockchains. We went through a hype cycle. And it's also possible the low fees were caused by a mix of the factors described above. And I don't think we need the rest of this article. So that brings us to 12 minutes on this particular session. And I think we'll take a break for the time being. So that again, we just covered why do Bitcoin fees become prohibitively high? Why are they now decreasing? What solutions exist to offset high Bitcoin transaction fees, such as SegWit, batching, and ditching Bitcoin? Thank you very much, and we'll be back for the next session in just a few minutes.
Hello, people of the internet, and welcome back to this next session of analyzing ETH gas. Now, we're going to look at how to look at the effects of different smart contracts and different variations of smart contracts and how they affect the ETH gas fees that are required. So let's take a look at simple ETH smart. Actually, I know what I want to do to look at a simple ETH smart contract. Loading contract. Here it is right here. How do you initialize Truffle project? We're just syncing the Rinkeby blockchain right now. It shouldn't take that long. It's on light mode. All right, let's deploy this smart contract. So what I want to do is I want to look at truffle.js. And see the gas and gas price. So we know that the default gas to send a transaction on ETH is 21,000. So let's try that in this smart contract. And we want to set gas price. Let's look up this handy helper on ETH, my Ether wallet.
unit converter. Come on, my Ether wallet. So 1 Gwei is equal to this many Wei. And this is one mistake I made before when I was using this truffle.js file, is I was putting it in as Gwei. So instead of putting this many Wei, I had 1 Gwei, which obviously won't work. We could actually try that. So let's try 1 Wei by mistake. Pretend we're making a mistake. And actually, one thing that we're going to have to do is unlock the wallet, which I forgot to think about. Which means I also need to Google how to get IPC Windows. First, let's see if we're syncing, then let's list accounts. Then let's unlock this account. There, it's unlocked. Whoops, what did I just do? So we're expecting an error here. Error encountered. Review successful transactions manually. Intrinsic gas too low, which means I'm trying to pay not enough gas here. So if I put this back to 1 Gwei and leave the gas limit at 21,000, it's still probably going to say the same thing. Yep, says the same thing. So I wonder if we look at my Ether wallet using the ABI here. Where is it? We want the build folder. Is there no build folder? Yeah, there is. So if I use the ABI, or the bytecode actually is what I'm after, and go to my Ether wallet. I wonder if my Ether wallet will tell us exactly how much gas this contract takes to create, or gas limit rather, because my Ether wallet's good at doing that. Usually, we'll find out here. We've got to go to Rinkeby. So let's try to deploy a contract. Yeah, it tells us exactly how much gas we need. That's with 41 Gwei, so let's try changing the Gwei, the gas price. See if it changes the gas limit here. No, it doesn't. But it tells us the exact gas limit we need. So let's try one less than that, see if there's a fuzzy barrier. Let's unlock our MetaMask wallet. Oh, we don't have a MetaMask wallet yet. See if we can get our wallet into MetaMask. I think it's just called dump proof key. Okay, I guess it's actually just in a folder here. So let's find out. We have a key store file. We have a key store file. I don't know the password. Probably my Geth password. There we go. We have some test Ether to use. Let's go back to my Ether wallet. Try it with one less gas limit than it suggested. See what happens. It was confirmed, yay. So there's a fuzzy barrier in there somewhere to allow just enough Ether to work. Ether gas limit. So we should have a contract on Rinkeby. No, it failed. Contract creation code storage out of gas. So it didn't work with just under the recommended amount of gas limit. So let's see if it works with just the right amount of gas limit that's recommended by my Ether wallet, which is 07. So we were exactly one way off of being able to create this contract, I think. Because I think the second time we tried it's going to work. And let's try this gas limit inside of Truffle with just a little bit more gas price. First, let's see if this contract on my Ether wallet worked. Oh, we'll find out in a second. Here we go. It worked. Successful transaction, which means we paid just enough gas limit for it to work. That's awesome. So Truffle doesn't actually tell us the gas limit it needs to work. So if we use one less than what it requires, exactly one way less, it should fail again. Or maybe it'll publish again this contract like we saw in my Ether wallet, but it'll give us the error that we saw again. Let's find out. Here's the error again. Contract creation code storage out of gas. Yep, so we have a transaction, which means the intrinsic gas wasn't too low. But if we take a look at the transaction, or when it goes to confirm here, actually it's on the next migration that we'll see it. So this one should fail, or we'll see the transaction fail if we look it up. Yep. Ballot contract constructor expected 1 arguments received 0. So we actually have an error in our migration here, because the constructor for ballot expects an argument. So we missed that when we tried to construct it here. Should be the number of proposals there are in the ballot that we're voting on. Either way, we should be able to construct it now. Because we told it to use 5 potential candidates. No, I don't know what I'm doing wrong here. Let's try comma 5. For the first argument, and only argument. There we go, it's deploying. So we should see this fail because it's just not using just enough gas. Yep. The contract code couldn't be stored. Please check your gas amount. So if we just use a little tiny bit more gas in our truffle.js, whoops, I closed it. Like the exact amount that my Ether wallet required, or even just a little bit more than that. No, we'll use the exact amount actually. So if we use a 7 here, see the area here on Etherscan. No, it's still not quite high enough. So I think that's because Truffle uses a little bit more to do its magic. So let's just throw it 705. There we go. We have a ballot contract. So to illustrate how not all contracts are the same, let's use this exact same set of settings inside of our Ethereum ICO contract. And see whether or not we can deploy it. See, we can't deploy this contract using the exact same amount of gas limit and gas price. It says your gas amount is not high enough. So if we go back in here and set it, oops, where's our truffle? And set it just a little bit higher. And see if we can deploy now. No, still not high enough. Let's try a much higher amount. There, we were able to deploy our sale contract. We're probably going to be able to deploy our token contract too. And there we go. We were able to deploy all our contracts using that much higher gas limit. And that just illustrates the difference between different smart contracts and how much gas they require. And we're up to about 23 minutes now, guys. So we'll cut this short and we'll be back with another session shortly. Cheers. Bye.
Hello, people of the internet. We're back and we're live, probably for another 15 minutes tonight. Cut it short just because I have to get to bed eventually. But what we're going to cover now is zero fee transaction blockchains. See how they work. See how they work and see if they can. Just a sec. So yeah, we're going to take a look at zero fee transaction blockchains like gas and EOS and see how they can work without charging any fees for transactions. So how does EOS work without TX fees? How no transaction fees on EOS? There are no miners in EOS, only block producers, which are voted on. As I understand, blocks that don't have enough transactions won't be accepted by the network. To learn more, you could probably look at the Steam white paper. Well, this is talking about Steam, we're talking about EOS. And block rewards are paid in EOS, correct? So with EOS, more will always be produced. There's no hard cap like Bitcoin. And if the value of EOS fell to $0.01 per coin, would all of the block producers quit and shut the network down? There's no hard cap, just like ETH. More producers will buy more EOS and stake more, increasing the value and increasing the reward they get for producing blocks. As in POS or DPoS consensus algorithms, block reward is proportional to how much is staked. So that's the answer. Basically, the people that stake EOS, so let's see if we can find them, get a percentage of the reward for new blocks. So let's see if we can see some of these stakers. Producers. So their daily reward is 828 EOS. I wonder how much that's worth. The top producer gets 828 EOS a day. They have 2.25% of the votes. So that's $5.96. So unlike Bitcoin, there's no miners. That's nearly $5,000 a day this guy's making just staking his EOS. So he has a whole bunch of EOS. I wonder if we can find out how much. Doesn't really tell us. It just tells us how many votes they have. Well, if it's 2.25% of the network, they have $12 million worth of EOS, and they're making $5,000 a day off of that. So as the price of EOS goes up or down, people will buy more and stake more, and then they'll be able to earn EOS passively just by staking the EOS, which means that EOS transfers become free just by the way the blockchain is designed. So let's take a look at gas and see if it's built the same way. So obviously it's talking about gas. Let's search Neo instead. Apparently, they're looking to implement a transaction fee. Wonder why that is. Malicious transactions. So I guess people are using free transactions just to congest the network and attack it. So this actually happened with a different blockchain, where people sent tens of thousands of messages at a cost of one burst. Wonder if I can find an example of that message. It took down the entire network, and trying to find an article on it. Somebody pumped and dumped it, but where's this message at? Hmm. Here we go. It's a different Steemit article. It's an article from the or a passage from the Bible, Revelation 8:7. It was sent to thousands of people, causing the blockchain to fork. And it was down for days. So I guess that's what people are doing for Neo now, using zero fee transactions, because this person's spent thousands of bursts to accomplish this attack. On Neo and Gas, people could use zero fee transactions to accomplish the same net effect. I wonder if anybody attacks EOS that way. No, there's nobody really talking about it. So Steam, by the same creator, prevents using the bandwidth model. In both fee and bandwidth model, there's some sort of bandwidth cap for blockchain stability. Fee model lets people post any fee amount with their messages to pay for bandwidth. They use, and miners have incentives to pick up the highest fee, but don't have to. So typically, you end up with highest fees processed first, and so on until bandwidth cap is hit, and the rest are pending. This ends up looking like bids and asks you see in trading, with low fee TX being high and risk low bids to pay less instead of market value. No guarantee they're hit. In bandwidth model, instead of using those incentives, you're guaranteed the bandwidth that is based on the percent of tokens you have time locked or vested. So it's basically the vesting model.
that benefits you if you try to send a transaction. If full bandwidth isn't being used, you can get more temporarily. In fee model, you can spend the network with high fees and prevent other TXs from being processed. That's not possible in the bandwidth model because of minimum guarantee. Because you can rent others your bandwidth and for dollars, bandwidth model can simulate fee model. Bandwidth model wouldn't work on a non-DPoS blockchain because there is no natural incentive like fees to include the transaction for the miner. But on DPoS, they would be considered not doing their job and fired, losing future time without job income by income amount of money. Same method is what prospects protects DPoS against censorship, malicious attackers, double production, and pretty much everything else. So the way that EOS works and the way that it protects itself against these fees is by having bandwidth that's measured and measured by how much you're staking and how many coins you have. And then if you have more coins, it's more likely that your transaction will be picked up. It's based on the total supply that you have of all the coins. So if you have one EOS and you're trying to send a transaction, you're less likely to be picked up than somebody that has 10 locked invested. And as we saw earlier, where there's people with, $12 million worth of EOS that have the largest share, and if they were to submit a transaction, theirs would be picked up first. Well, that's about it for this session of the live stream. We're just going to talk for probably 2 minutes about you guys and me and how we're going to move forward. So today I completed basically 1.5 live streams full of offline recording and live streaming here with you now. My live stream isn't telling me how many people are in here or how many people have followed me and all that fun stuff. But if you guys just want to drop me a follow, I already have 2. I'm very happy to have a second one while I was offline for a little bit, and it kind of motivated me to get back into the game. So if you guys just want to drop me a follow, that'd be great. And I should be here every day for the following 4 or 5 days with more live streams. I should have 2 tomorrow, which have been approved, and I just need to create an intro video and splash screen and a description for those 2, which I should hopefully get done tonight. Yeah. Well, that sounds good, guys. I'm glad everybody's here. I'm glad everybody's happy, and I'm glad everybody's watching. And I think that we have a bright future here together. And I just want to thank you again. And we will be here tomorrow to continue this live stream in the morning or in the early afternoon. All right. Thank you.
Hello, people of the internet, and welcome back to this next session of how to analyze gas usage on Ethereum and other blockchains, other fees on other blockchains. We're here with this next session where we're going to look at a potential use case for zero fee blockchains, where it's what I like to call a drip drop financial rewards and wages system. So basically, the way that would work is, say, come on now. Come on now. Say someone has a monthly pay. The employer or the person, the hiring party would put up the $4,000 onto a blockchain. The blockchain then optionally vests the amount in the name of fees, payer, payee, or some combination. And then what happens next is it's divided into just smaller batches by the minute or by the hour. So if we have $4,000 divided by 4 weeks, divided by 40 hours. So if we wanted to pay them $25 an hour, each and every hour, via feeless blockchain. So we talked a little bit about different blockchains in the last session. So I'm going to power on my Ubuntu here, just to show you that I'm already working on this. Now, I tried to talk to the people at IOTA IOTA Slack? No, Discord. So IOTA is one feeless blockchain that we could use, but the issue with them is that they don't actually have smart contracts live on the IOTA blockchain yet. So we could create an IOTA account that's IOTA transfer JS that takes the amount without being trustless. So the IOTA account would hold the amount and then send a fee or an hourly payment once every hour out of the total. So, I mean, let's just have a look at how that would work. So I got some IOTA testnet tokens. So there's a message that you can send along with the transfer, which is good because that's what we use to track. Now I just want to show you that I already did this for Steem, which is another feeless blockchain. So here's my bot that I have running on Steem right now, and I'll actually put the link to my Steem announcement about this. But I developed it all offline just to see if I could actually do it. So here's the article for how to use my Steem bot to pay drip drop feeless hourly payments on Steem, and we'll throw that in the description. But let's look at how we could do it on IOTA. I wonder where we installed IOTA too. It's Electron for sure. Let's figure out how to install IOTA. Because I already did this and I already got 1,000 testnet tokens, which you actually had to ask for. So here's my testnet IOTA wallet. I need my seed.
So here's my balance by iota. So what we need to do now is create some other iota addresses. So let's make sure this has no balance. So here we go, we were able to list the last transactions. Let's just comment out the rest of this stuff. Actually, we do want to send it a transaction. So where's my receive iota? Let's try to send it one iota with a message. Now in the message we want to send it something like how many days to send minutely transactions, and then the account that it gets sent to. So we'll send it one, and we'll send it back to the first account, which is come on, iota. So 7 days, we want to send it to this address. Let's try running this. How does it know to include iota?
And then we need to connect it to the same testnet that our wallet's connected to. Iota display balance JS. Unexpected token import. Cannot find module iota. Let's try actual iota.lib.js and download that file. iota.lib.js. You can't use WinZip apparently, that sucks. Downloads. Open with. Do I have WinRAR on this thing? No, I don't. Well, let's just copy the tar.gz into Linux. So we really want the iota dot. Here we go. You can actually install it using npm. So what we need to figure out is why npm won't let us import. We got to get this import statement working. Working. What's up? Okay, well, I'll get them in like half an hour. Don't do them, please. This is layout API.
Let's try this code. I'm getting an unknown protocol on SSL. SSL. says I can roll back the node and apparently get rid of this error. So I guess we'll break this video short here while Node installs. We're going to go ahead and rename our session to align with what we've been trying to do. And we'll be back in a minute.
Alright, we're back. We managed to fix the SSL error. It was just a matter of changing the port here to 443 because it was originally in the string here. We said port 80 and port 443, which obviously don't want to work together. So now we're seeing the balances of the both addresses because we went ahead and transferred one using this send transaction function we got. So now we want to get last transaction. And see what we can see in these transactions. C2 is not quite seed bot. We're going to call that C2. And here's our message from the transaction. So it's actually console logging the message. And it did it for both accounts, and the most recent transaction on both accounts is that same transaction. So we only want to do it for the bot account. And we don't want to do the last transaction, we want to do all of the transactions. So let's see if that works. No, I wrote something. Let's just go ahead and send another transaction that's like that one. But instead we'll do 31 days. And here it is, sending it on the blockchain. It should give us a confirmation here in a second. Here's our confirmation code. Okay, what did I break here? Code. So we can comment this out again, because we don't need to send another transaction. Somewhere in here I have underscore TX. Oh, we have TX here twice. So we don't see that balance reflected yet. That's not the message we're looking for. Something in our loop is messed up. Let's change this around a little bit. Because it's messing up our second message. Also, why is it not showing any balance on the first address? I think I ought to actually changes here. Address each time you get a transaction. address to this email address. So why is our message all messed up? I guess it's long -1 code that we have. Message is not defined. Oh, my internet died. Use our address anyway. Use our address too. There we go. Now reflecting the balance. Okay, what broke here? Something to do with our list is not working the way we expected it to. That runs. I wonder if we can invest IOTA. Okay, so let's just see what we broke here. Okay, so it's got the right stuff sometimes. RTX, so let's just get rid of this for RTX equals. What's the original code? I don't know what the original code was. Let's try 0. Let's just control Z. Actually, let's control Y. Yeah, control Z until we find out what it was. 0. So let's just try 0. I wonder how many decimals I would have this. Okay, here we go. putting in the same message over and over again. Look at it right here. So this count plus plus should be inside here. Try it again. Oops. See now, the address that changes over time. I think when we send it one transaction, it's being got. But here's our messages anyway. Hashes. Hashes. Dot push. tx2 dot hash. Anyway, what we really want to do is put get transaction inside of a set interval. What we want to do is for hashes, how we want them is so we'll do messages tx2.hash this for our hash and hashes every minute. Store the message, the original message. We're going to get the messages. Messages as this. I'm going to split that based on space. The amount is going to be split parse float split 0 divided by 24 divided by 60. So that's the thing. It starts with the whole line remaining. For our hash and hashes, constant from log, messages, hashes, hash. Then what we're going to do is send information.
No broken site. No, we can't just this way. So I guess we just get the new address then. That's where they generate a new one each time. MBIR. Let's go generate this. We'll do it using unused addresses. Okay, we'll just try sending one to each of these. So I guess our first two messages don't make sense because we have to provide the seed, which we can't do. Blockchain. So we're gonna have to use some kind of offline or off-chain solution for that. As long as no outgoing transactions have occurred.
so we can send to the address. Let's see what happens here. Oops, the same transaction. Seed, address, amount. Message. Let's see if we set a timeout to start this faster. So how much is an item worth? So I wish I had a whole bunch more iota. Okay, let's see what these hashes are. So that means that the amount should be this. These may be power over too. So, more. So let's pretend I said 997 tiny iotas. That's not what I did. Just send a transaction with a message. Or is that other fashions? So now just has the IOTAs. So here's our 3 hashes. It's going to ignore the first 2. Okay, so it's 40 seconds. Invalid transition subject. Well, the value is not what we're expecting. And that's not right either. That should be multiplied by value, right? Here we go, it's sending it, and it's going to confirm it here in a second, and we'll be done this particular session. Here we go, it confirmed it. So it's going to be good to get in an hour, but let's just see if we can see that now. Let's go with that seed. So that's this first seed. So it should be just 41 ounce if that worked. It might not be confirmed by the blockchain yet though. Okay, it's going to break all of them. Let's see if we can this one. It's actually tracking hourly pay transaction. So what we want to do then is we want to if message is not equal to the balance is 0. That's because one of these old addresses was reused. Oh, here we go. It's incoming 41. It's FYI. So the balance should update it. But there's a transfer. It's pending. So we'll just wait for that. For another 7 minutes or so. Oh, we sent another one. We restarted the script. That's my bad. But there's no error because it's trying to figure out my hourly pay issue. By the way, that should be good. We'll see that coming in a sec here when we restart the video. Cheers, everyone. Oh, I'm sorry, you can't see me.
Hello, people of the internet. We're currently publishing a video update to the last 50-some minute video that we created because I forgot to wear my headset. So now that I'm wearing my headset, let's check out my audio levels. They look great. Let's throw some music back on. And take a look at Heroku where I just reset my password. So in this particular in this session, we're going to go ahead and look at how to add a fee to our project that we created, which is a feeless drip drop payment platform. I still didn't do my password right. Let's try an easier password. There we go. So we need to relaunch our virtual machine, which I stopped because I was trying to run this video export. So hopefully we can run OBS and virtual machine and the video export. So we need to add a fee to our little bot here. So we're going to take 2% of whatever is sent to this IOTA address. What else do we want to do here? We'd like to add Express in here. We'll make it refresh every 120 seconds. And then when we publish to Heroku, we'll put it on the mainnet. Maybe we won't for the purposes of the demo. We don't want to include node modules, so let's go back to find a git ignore here. Let's see if that worked properly the first time. Nope, there's an error. Let's find out what the error was. So node one wasn't installed. Let's get rid of these dev dependencies and throw them up here under regular dependencies. My battery's running low. So I think it's going to pick up on our 997 IOTA transaction again and send it as another 41. Although we don't have a number for fees for some reason. Let's find out why not. So what's 2% of 997? So the fee should be the total amount, not divided by 24. Just put in some basic logic here to see if it's actually a number. So add some more logic in here to only add a hash if it doesn't exist in the hash list. Oh, and we're expecting to see 19 rounded down here for the fees, which is what we see here. So now we know all that stuff's working. Now let's put it on the live net.
Testnet wallet, I guess. Either way, my seed should be a live net address. Let's find out. Hash is not defined. Broke something. So that seed does work on LiveNet, which is good. Let's publish this on Git. There's actually one more change we need to do. Yoda. A couple other things to change here. We don't want to do any of this stuff if the transaction's already included. Let's just add that right quick. Because it added our fee in here twice. We don't want that.
So we should let this run for 2 minutes before we know if it's working or not. So at 20, we should know. So here's the first run where it's going to add 19 to our fees. There it is. So let's see if our fee is still 19. And it is, so our bot's working now. The next thing we want to do is update the node to one that's on the live net. And now we have open source quote code for you guys to take a look at. Well, that's it. We're up to 30 minutes, which is just over 4 hours. So hopefully, my category manager will accept this particular project at 4 hours, and we can move forward with additional projects at 5 hours. Otherwise, you'll see me back on this particular stream or recording for an additional hour's worth of content if it's not approved. All right, thanks a lot.